Hello everyone, this is Bradley. So today, this is a voice recording in which we're going to do the prompt 8th of November 2021, in which is blue. So my intention is to make a rain ripples kind of effect as I've done for the six-sided umbrella. But this time, definitely, we're going to improve the methods with the newest presets. You can always download these presets for free from the link in the description. So let's start. So here we're in Blender, and the first thing we're going to do is to create a default plane, and then I'm going to create a ring model. This is Nodevember, so it's ideally speaking, we should create everything from scratch using nodes. In real life, you should probably do this using manual modeling. Otherwise, this is too stupid to make just a single ring. But I think this is how it works. Whatever. So let's take a subdivision surfaces. So to make a ring, basic idea is that we are going to use this square. So let's take it 0.1 because this is a ring which is supposed to be very small, and let's elongate this z a little bit. Okay. Next thing, I'm going to scale down this bottom face. So float compare, and we're only going to affect the bottom face when the z is smaller than it. So I think this is what we're going to do. Let's take a vector math. Take a multiply to the positions. So now we can actually see its effect. Okay, so this is kind of okay. Let's increase the z. So now we have this raindrop. Okay, this is really good. I'm going to just group this so that I have a raindrop. So Control G. This is a raindrop, and I'm going to add a fake user just in case. Okay, the benefit of this part is that we have this origin at the bottom. Okay, so this is very important when we do the further manipulation. So here, let's create a grid. I'm going to place this grid as I wish. So let's create an empty. So I have this empty. I'm going to use a preset which is called parenting. This parenting isn't very special. In reality, it's just a transform node plus object info nodes and so on. Okay, so now we can use the empty to actually control the position of this plane, which is very handy. Next step is I'm going to use the point distributes preset so that we can not only distribute the particles but also set the amount. So I want to set maybe 5,000 particles. Let's see if it is really 5,000. So the actual amount is 4,950, which is very close. So yeah, which is very nice. So there are some inaccuracy because of the formula, but anyway, I think it's very good. Okay, another thing is I'm going to create another grid just as a ground. So here, let's take a recast. But this grid, we can do this later. Here, right now, I just want to work with this plane. Okay. Next thing I'm going to do is to take the raindrop. So point instance. So we have all this kind of raindrop, but it seems too large. So let's decrease it. So first, let's take a randomness. So I can have a random scale. Take the values into the scale so that all uniform scales, then decrease its average size. Okay, so this is one part. Next part is to rotate all this. So we can still use this randomness. We can change the seeds. Take the vector into rotations. And let's eliminate this average and increase some variances. So here, if we take a translate instance, and if it's moving on the local space, you can actually see they're moving towards different direction based on the rotations. Okay, so this is okay. And this is kind of intended. I want to rotate this entire ring in general. So here I'm going to do a vector math a little bit. So let's, I think it should move on Y. Okay, so now we have a tilted to this direction, which I think is good. Okay, so again, by manipulating this Z, everything is falling. Here we're having a bug because I'm using the same magnitude of this translation, but they're translated in a different magnitude, which I don't think is intended. I think that we can observe that the smaller one is going slower compared to bigger one. So something is wrong with the scale. Yes, something is related to scale. I've heard these kind of bugs about the rotation, but I think it's equally true to the translation now. So we have to figure out a workaround. So let's turn off this local space so we do not have this effect from the scale, but we also lose the effect from this rotation. So we're going to reconstruct the rotation by using the rotation to vector, so that now immediately we do not see many things. So if the scale is 0, then everything is just in the original place, but by manipulating this scale, we're having this vector. So we reconstructed the local vector. Okay. Next step, I'm going to do the recast. Actually, I probably do not need this translate instance because, so let's take a set position. I'm going to recast on the ground. Previously, we've made a second grid because I need to cast on this ground or water surface. Take the hit position into position, then everything is setting in the ground. And to make the morphing, we can use mix RGB or mix vector. Because this is a specific case, so I think I'm going to choose the mix vector so that we can overshoot this vector. And I definitely need the position, so take the position into the vector A. The reason of overshoot is if I type the vector 2, then it again goes down more. So this is the concept of overshoot. Okay, mix RGB node cannot do this, so we have to do this. Yeah. So now we're having, let's eliminate this translation and plug this vector into the redirection. So now by manipulating this vector, we're going to the ground. Okay, I think this is fine. So let's take a delay forth, and I'm going to take the forth into the vector. By manipulating this time, we start to have this kind of rainfall. It looks kind of very beautiful, but there's orders inside this rainfall. I think this is due to how this distributed point is being generated. So we have to fix this issue by randomize that. I've explained in particle tutorials that if you want to randomize the order, then you take this off. But on the other hand, you need to tell the system how many instances that you need to create. So let's plug these instances into maximum. So now if we play this rain, then we have all this kind of everything's randomized. Also to know that this is not the same, this randomization is not the same as the shuffle list presets that eliminates all this kind of repetition. So it's very possible that two droplets is falling at the same rate, same time, but that's another story. In this case, I think it will be fine. We can increase the step, or we can decrease the step. We can increase the duration, or we can decrease the duration. I think this is fine. Okay, so next thing, we're going to add some noises during this evolve. So this evolve goes from value 0 to 1. Okay, we probably want a little bit overshoot, but we are also going to remap that. And if we are remapping with float curve sort of things, then we have to keep this value as 0 to 1. Okay. Here, let's add a noise 3D. Noise 3D is basically the same as the noise texture, but I added several more functions. The most important thing actually is this mid-level, because otherwise you have to add a vector mass and subtract 0.5 so that you balance the noise out. Okay, so now if we play this animation, then we should be able to see kind of noise. It does look like kind of a snow if you realize. But one issue that if you increase the frequency to high, then it should be very jaggy. However, we do not see this effect. It means our noise is not moving, because it should not move. We're not evolute, we're not changing the vector. So here what we do is, I suppose, let's just take this forth into evolution and play this animation. You can see it becomes very jaggy. This is definitely not desired, but it also illustrates that our animation is actually moving when they are falling. So I think this is kind of nice. So you can decide a nice enough frequency amount during the animation. It looks more kind of snow than the rainfall, but I think I will keep it for the moment. So we have finished the rainfall part. Next, we are going to move on with the splash. So splash is something we have done already, but let's take a curvilinear node. Curvilinear node is basically just a curve line. Let's also take a bevel curve so that you can see. But I added the offset because sometimes I want it to offset or something like that. Okay. Here, let's take a set position. Let's take a curve parameter to the factor combine XYZ so that we can change these offset. Curve parameter is basically from curve start to the end, it's 0 to 1. That's why it's elevated. But we're going to take a float curve and to remap it. Okay, something like that. So now we have this nice. Let's decrease its value a little bit. Okay, so I think this is good enough, and I'm going to replicate this whole thing. So let's take a point instance, and I need a circle, curve circle. Take the resolution to 5. Take the circle. So now I have 5. Let's take it 0.01. Take a normal. Align. Ruler to vector. Take the normal to a normal. Vector to the rotation. Yes. So now I have this 5 whatever stuff. We're going to make it as a path so that our droplets can follow. Here, let's take a randomness and take the value to scale. I think this is fine. Okay, so once we have done this, we can try to use the preset to follow the spline. So let's take a so let's show this instance and follow spline. So this is also a new preset. At the moment when I was working with last project, I do not have this preset. I think this is too much. So let's take a point instance, or instance on points. Where's our raindrop? Yes, raindrop. Take this mesh. So we finally have this rotation goes to rotation. Yes, it works. The scale goes to scale. So we can use this scale to control. We can also add the variances, just to make it a little bit more convenient. I do realize one problem. That's feels like the rotation is going the opposite direction. So let's take a Euler, rotate Euler. I've heard the developer says they may change the name of these nodes. I do not know what they will change, but yes. So this is the basic concepts. of this kind of a splash to make it more organic. In the last noding, you probably didn't see this process, but this is kind of a reality of what I've done. So let's take a Control J to group it. Okay. So there is one thing I would like to do is once they reach their destination, I would like to kill this particle. Okay. So we need to take this scale down. Here, let's take a math, and I'm going to multiply. And I need to prepare for a float curve, or actually a color ramp, and make it, I think it's 0 to 1. It should start with, let's give it a larger size, and when it's reached the destination. So black on both sides means if you're reaching, so if your factor is 0, then you have no scale. If your factor reach 1, you also have no scale, but you have a nice scale when you are in the middle of everything. And we're going to basically using the same factor to control the flow of this entire thing. So basically this is kind of idea. So we can tweak more stuff. For example, take the white in middle so that the higher it goes, the smaller it will be. So these are kind of things that we can play around, but this is the concept to make it appear and disappear for a single unit. Once we have finished this single unit, we're going to instance that just like we instance the raindrop. Here I need this destination of our rain droplets. So let's take a instance 2 points and add a reroute, because I want to set the positions to our hit position instead of the mixed position. So now we have all these kind of points on the ground. Let's take a point instance. So instance our circle first, and then use it to instance our line. We can decrease the scale, so let's take 0.1. We have all these kind of endpoints, and we have all these kind of instances. And playing this animation, we have all these kind of splashes, which is okay. So here, let's take a join geometry. So I'm joining this ring and splash together. So now I have these two animations. We can still play around the splashes. So the reason I do this is because I want to compare the scale of these two systems. The splash should not be larger than the original ring, and their size difference shouldn't be changed too much. Okay, I think this is cool. Before we head into further, there are several things I would like to change. One is, when you're creating a system, it'll probably be better if we start with tiny bits, maybe 50, so that you can actually observe all this kind of difference. Another thing is that this tree is going to be, it is already very big. So I'm going to use the time info so that I do not need to change this time. So let's take the factor to 1, take this time, and increase this animation to 1000. So basically I want to observe all this kind of rain falling down, and next we're going to link this delay fall to our value here, so that we can actually control this animation. So here, when we're talking about the delay that we generated earlier, there are several issues you need to notice. When we generate the delay, this fall for this time, they are generated based on this geometry or this geometry. Actually, they are the same because they come from the same reroute. Okay, but This value, however, is working with this geometry. When the geometries are different, the values will be changed dramatically, which means you can not directly plug this fourth into somewhere. So this is a very kind of interesting issue, especially if we have an instance on points in the middle. It will cause more problem than you can imagine, because the list length is changing. Actually, we changed not only one time but 2 times, so things will not match each other. In this case, it will be better if we just transfer attribute. I'm not sure if I need to make a tutorial talking about this transfer attribute. Maybe people will think it's unnecessary, and no one is watching this channel anyway. So let's take a time. We also need to make it depends on the index. Okay. And here, if we use this transferred attribute to replace it, likely it won't really work. Actually, here I do not see anything. It's probably because the value is 0. Oh, there is several things. First, we have a warning. It says instances are ignored. Because we do not have this, so in this case we can use the instance on points. They're essentially very similar because it's really just the list length has not been changed, so it can be used, but it's still not working. We do not see anything. So in this case, we do not see anything. Is likely because it's either 0 or 1. I would think it's probably 0. But how can we resolve it? There is one thing that we should notice, that we're working with instances, and it has not been realized. So we need to realize it first, and it's still not working. Actually, we can see some effect, but it's very fast. So a key within this kind of delay fourth is we need to remap the time for duration. So if it's 25 frames will generate a fourth from 0 to 1, which means the duration is 25 frames. And it works. Looks definitely ugly, but we can deal with that. Yeah, looks kind of okay. Let's take the scale variances to low. Okay, I think this is already good once we have it. We can confirm better if we increase the step interval, so that's, yes, it looks kind of nice. Okay, so next step is I would like to have all these kind of rain droplets disappear when they hit the ground. To do that, we're basically repeating the same process as we do with all this kind of splash. So we use a color ramp, and I need to take a scale. So color ramp with the fourth. If the fourth is at 0, I do not really care. If the fourth reaches 1, then it should be black, which means the scale is 0. Here I'm going to take this initial point as white. Okay, so we have this scale. We can play this timeline, so we see the animation. And we do see some issue. That's, so they hit the ground, and there's lots of raindrop splashes which occur at the same time. The reason it happens is likely because the list does not really match. So here we need to do an index converge. Let's move it. Index converge in this case is basically to remind all these kind of instances that they should be in a group. So 5 droplets should be in a group of these splashes, and then we create an index per instance. And let's check. Yeah, now it actually works much better. You can actually see these 5 droplets are a group. They occur at the same time, and the other 5 droplets are all occur at the same time. Okay, so now to solve the problem, we can change all these kind of parameters. For example, increase the values, scale, or change all this kind of stuff. So these are something that we can tweak after this video. But yeah, the splash works kind of pretty nice. One thing I want to add is I'm going to rotate this rotation. So how should I do? Let's take a combine XYZ, take another randomness. I'm going to change the seeds, decrease the relative, pi times 2, take the value to z, and take this rotation, so that you do not really see an obvious pattern of ring droplets. Okay, so this is cool. Actually, this looks kind of flower patterns when they splash. Now we have this ring. We also have this splash. Everything is correct. We are going to move further that to make kind of ripple effect on the water surface or ground. To do that, we need a grid that we will generate at the most beginning on the ground. We also need this instance 2 points. Okay, so these 2 nodes, because we're going to generate a proximity fold based on that. So very often we're using proximity fold by using object or location offset or scale offset. But in this case, I'm going to untick this box so it works with geometry and the maximum distance. Let's plug these instance points to geometry. And I want to use these fold to generate the sine waves and finally displace our plane. Here, let's combine XYZ. And we can plug this fold to Z. We can see the effect is like displacing the plane. Let's add a subdivision and maybe 7. So here it's not very obvious, but essentially this is kind of Voronoi effect, which is still not my ideal. So let's take a sine wave, a sine function. Talking about sine function, there are several things we need to take care of. One is its frequency. So when we generate this fold, these values still goes to 0 to 1. But instead of using scale offset and location offset, there is another parameter being used, which is talking about the distance. Here, let's decrease the distance so we can actually see we're limiting the effect of this distance fold. We can also increase the frequency, so it becomes more wave-like. We also have this amplitude, so now this becomes a very unique structure. I'm going to use the same fold for 2 different values. So one is the value which calculates the distance, the other is the amplitude we're going to do. So here, let's take a multiply. Let's times 0.03. Yes. The reason to do that generally is that we have a fade off effect. So the center is very high. the rest of the side is start to fade off, so you do not have a jaggedness or abrupt disappearance of this wave. Then by manipulating this distance, then we can see this wave. So frequency is another parameter that we can play around. Another is the phase. So if we increase the phase, it's going outwards. Here let's increase, here let's take another mass and multiply, so that when this fourth is working, then it will move outside. So now we have this basic wave, but the question is, how can we make it appear as our raindrops hitting this water surface? I think this is going to use the same method as we are doing with the water splash, because either way this ripple effect should occur at the same time as our water splash. So we still need to use this time. Do we need to transfer it? I guess yes. So let's duplicate this transfer node and even the map range. I have these two nodes. Shift D to duplicate, Alt P so that it goes outside the frame. I hate this kind of a newest. Yes, okay, let's take this time, and I also need the geometry. This time, instead of using the index, I'm going to use the nearest. Here, let's take this linear range, this map range to the amplitude, and it says this instance are ignored. So we still need these instance to points. Yes, where's our instance to points? Oh yes, this here it is. Okay, so now we have this, and I'm going to take another map range to the face. Previously we used the face from the proximity fold, but our proximity fold is really just for a setting inside of the animation. That's why we should not really use that. That's a mistake. Even for me, sometimes I make a mistake, even if it's during a tutorial sort of things, because it's just a kind of nature. Okay, I think this is good. Can we actually use the same fold to manipulate it too? Something like that. So if I take this, okay. So this fold goes from 0 to 1, or this fold goes from 0 to 1. Here we need to manipulate the float curve, so that amplitude goes up but also down afterwards. I think the nature of this proximity fold is a little bit bad, because you have all this kind of Voronoi pattern. I probably do not have a real way to solve it for the moment. I probably do have a way, but sounds to be a little bit difficult to think about. Anyway, so now we actually combine all the animations. So plug the two geometry, join geometry. So we have a rain, we have all this kind of wave, we have sort this and that. I'm going to take another multiply so that I can eliminate the effect from the wave. Okay. Okay, then we finished. finally, it's just essentially all about the tweakings, all these kind of parameters. 0.4. There are many different controls, like this wave, splash, the scale of the splashes. Maybe they can go higher, but I think this is it. I admit this is a quite complex tutorial, but I would say maybe this is the nature. Oh, another thing I want to remind you is there's a loop function I added. So you can play this animation and these raindrops can loop throughout forever. So once they finish, they add, actually we find a bug here. Yeah. Our fourth is looping, but the time is not. Interesting. I need to fix this bug. This is kind of good part of working with to remake the animation, because you can always prove your concepts. Let's take a sound. I hope it will actually work. The thing I'm worrying about is actually this variance, because it disrupts the duration probably. I'm not 100% sure. This is just a quick fix, but it seems working. The good part of this looping is that I can use less amounts of all this kind of raindrop or particles, so that it does not disrupt the stuff too much. And this is completely procedural, so you can increase all these kind of raindrops and so on and so forth. This kind of ripple effect can definitely be done better. This is also a mistake, but if we do not use the proximity fourth, then we probably need some more complex process, which I do not have a very specific opinion at this moment. But yeah, I probably will tweak more before I publish the animation, but this is a voice noding. So I want to illustrate making such kind of effects are never kind of easy. You will encounter accidents which is beyond your hypothesis, and you have to solve the problems as you go, and you find out the bugs and so on and so forth, kind of stuff. So I hope you enjoyed this video. I'll probably see you next time. Bye bye.